Mr. Saari. There we go. All right, so this is a 2.5 warm-up. This is a problem from lesson 2.4. So let's try this. So given that -1 is a 0 of f of x, and f of x is x cubed minus 4x squared plus x plus 6, we want to be able to solve the equation x cubed minus 4x squared plus x plus 6 equals 0. So essentially what we have here is we're told that the polynomial within our equation, we're told one of its zeros. And when we're told one of its zeros, that means if -1 is a 0, the factor theorem tells us that x plus 1 must be a factor. X plus 1 must be a factor. So remember, if x plus 1 is a factor, that means we can divide this by x plus 1. And using synthetic division, we can reduce this down into a quadratic, since this is already x cubed. We can reduce this down to a quadratic, then we can solve and find the remaining zeros with the quadratic formula. So let's go ahead and do that. So we're dividing by x plus 1, so -1 goes in our box. Let's make this a little smaller. And we put our coefficients, 1, -4, 1, and 6. 1, -4, 1, and 6. Bring down our 1. Now we multiply, -1 times 1 is -1. Adding down, we got -5. -1 times -5 is 5. Adding down, we got 6. -1 times 6 is -6. Ah, yes, perfect. And we got 0 as our remainder, which confirms our factor theorem that x plus 1 is a factor. So what we've just found out is that since we divided by x plus 1, we know x plus 1 times our resulting polynomial here, which is, remember, this is x cubed. This was the x cubed term, then x squared, then x, then our constant. So that means we go down by 1. We reduce these by 1. So this is the x squared term. So it's 1x squared minus 5x, and then plus 6. And now we can use factoring or the quadratic formula. I'm going to use the quadratic formula because that is our foolproof method, but I believe this one does factor, so you could use a factoring method to find the zeros of this. So remember, our first zero is x equals -1. That was given to us, but I'm just rewriting it to show us where it came from. And then for this one, quadratic formula, x is equal to -b, so that's -5, so positive 5, plus or minus the square root of b squared minus 4 times a times c. So we've got all over 2a, so that's all over 2 times 1. So 5 plus or minus the square root of 25 minus 24, all over 2. That's 5 plus or minus the square root of 1, which is 5 plus or minus 1, all over 2. So we've got 5 plus 1 over 2. That'd be 6 over 2, which is 3. And 5 minus 1 over 2, which is 4 over 2, which is 2. So we've got -1, 3, and 2 as our answers. And there we have it. This is very closely related to the subject matter and content of lesson 2.5. This is a little bit different. We change it up, make a couple small tweaks. So it's important to keep this in mind as we're entering lesson 2.5. All right, so lesson 2.5, we're going to use the rational zero theorem and see how we use to solve polynomial equations. So for our learning targets, after this lesson, as the student, you will be able to make a list of all possible rational zeros of a given polynomial, and you'll also be able to solve any polynomial equation using the rational zero theorem and factor theorem. And the rational zero theorem is what we use to make our list. So we're going to make a list of all the possible rational zeros, then we're going to use that list in conjunction with synthetic division to solve any and every polynomial equation. All right, so what's different about lesson 2.5 compared to lesson 2.4? So they're very similar, both of them. So lesson 2.4 involved nothing with the rational zero test. Lesson 2.5 uses the rational zero test. We'll talk about what the rational zero test is in a minute. But so essentially what we learned in lesson 2.4 was we learned how to find zeros of higher degree polynomials, meaning like finding all the zeros of a cubic function. But we needed info about at least some of the zeros. So for example, we needed to find the zeros of this, given that 1 is a 0. So we're told that 1 is a 0, which would have meant that x minus 1 is a factor. So I would have started off by dividing this by x minus 1 with synthetic division and going from there. For this one, notice how we know nothing at all about it. We know nothing at all about it at all. No additional info needed. So you won't need the crutch of being given some information about the zeros for lesson 2.5. If you're excited, me too. Let's rock on. Okay, so first learning target. How do we make a list of possible rational zeros of a given polynomial? Well, use what's called the rational zero test. First of all, let's answer the question, what do we mean by rational zeros? Well, a rational number is a number that can be expressed as a fraction of integers. Expressed as a fraction of integers. Integers being like number line numbers, negatives, positives, and 0. But we're going to be creating a fraction based on this. All right, what we're going to do is to find the list of all possible zeros of a given polynomial. What you do is you put all the factors of the constant term, factors being numbers that multiply to get the constant term, over all the factors of the leading coefficient. Well, let's define these two underlined terms first. The constant is the term without an x. It's the term with no x. So that would be this one right here. So the constant term is the term with no x. That would be 4. Okay? What about the leading coefficient? Well, the leading coefficient is the number in front of the highest power term. So 3 would be our leading coefficient. So it is the coefficient, the number in front of the highest order or highest degree term. Okay. So what you're going to do is you're going to put all the factors of the constant term over all the factors of the leading coefficient. All right, let's start by doing that. All right, I've used all my space here, so let's create a new. Here, let's actually take a picture of this if you need to. I'm about to erase it to make a little bit of room. Actually, let's make this a little smaller. That didn't work. All right, I'm going to erase this to make a bit of room. Okay. Rewind the video if you need to go back and get those definitions. All right, so all the factors of the constant term. The constant term is 4. So the factors of 4, let's do this one in red. Struggle in here. All right, we're going to do the factors of the constant term in red. So we want the factors of 4, things that multiply to get 4. You got 1 and 4 and then 2 and 2. So 1, 4, and 2 are all factors of 4. And you make them all positive and negative. So you've got, factors of 4, you've got plus or minus 1, 2, and 4, all plus or minus. Because remember, you could have both being negative or both being positive to make them multiply to get 4. Okay? Over all the factors of the leading coefficient. Well, factors of the leading coefficient, those are factors of 3. Fortunately, we have fewer of those, so we just have 1 and 3. Since I made these positive and negative, I don't have to worry about these being positive and negative. So we say 1 and 3. So we've done this part right here. We put all the factors of the constant term over all the factors of the leading coefficient. And now we're going to create all possible fractions by choosing one factor from the numerator and then one factor from the denominator. And each and every option should both have a positive and a negative version. So that means plus or minus in front of each one. All right, so here we go. We're starting with the 1 here. We're going to make it 1 over 1 and then 1 over 3. So I've got plus or minus 1 over 1 is 1. 1 over 3 is 1/3. So those are my first two. Second two, I'm going to do 2 And we're going to do 2 over 1 and 2 over 3. So plus or minus 2, that's 2 over 1, and plus or minus 2/3. These are all possible zeros of this polynomial that we're creating here. And then for this last one, I'm going to go with the 4. I'm going to do 4 over 1 and 4 over 3. 4 over 1 is 4, so plus or minus 4. And then plus or minus 4 over 3. And this right here is the full list of possible rational zeros. These are the only rational numbers, the only numbers that, pretty much only normal numbers that are non-square roots. The only numbers that possibly could be factors of this polynomial. Okay, so I'm going to do an example, and then I'm going to have you guys do one. So we're going to list all the rational numbers that could potentially be zeros of the given polynomial. That's just another way of calling possible rational zeros. So we take all the numbers, all the factors of the constant term. So that goes on top. So we got all the factors of the constant term factors, over the leading coefficient factors. Leading coefficient factors. All right, so factors of our constant term. Our constant term is 9. Things that multiply to get 9, I got 1 and 9, and then 3 and 3. So basically 1, 9, and 3. So I've got plus or minus 1, 3, and 9. And they're always going to be plus or minus. Always plus or minus. Leading coefficient factors, I've got just, so 3, which is just 3 times 1. So 3 and 1 are our only factors. So 1 and 3. Okay, here we go. So now we're going to create our list of possible rational zeros by making every combination of fraction, picking one number from the numerator and one number from the denominator. So I've got 1 over 1 and 1 over 3. So there we go. So plus or minus 1 and plus or minus 1/3. Second, I've got 3 over 1 and 3 over 3. So 3 over 1 and 3 over 3. But 3 over 3 is 1. We already have that one, so we don't have to worry about 3 over 3. But 3 over 1 we need. That's 3. You just don't have to do any repeated values. And then lastly, I've got 9 over 1 and 9 over 3. 9 over 1 is 9. That one hasn't been accounted for yet. But 9 over 3, that simplifies to 3. We already have that one, so we don't have to worry about 9 over 3. So we only have 8 different possible rational zeros. Notice there are 4 of them, but there's a positive and negative version for each one. So that's our answer for possible rational zeros of this polynomial. All right, now it's your turn. Go ahead and try this problem. Go ahead and pause the video. Solve the problem below. Good luck. Unpause and ready to check your answer. All right, you've unpaused your video. That means you are ready to check your answer. Let's list all the rational zeros that could potentially be zeros of the given polynomial. Okay, so we're looking for all the factors of the constant term. So we want the constant term factors. And we want to combine them in fraction form with all of the leading coefficient factors. Okay, I'm going to do this one in red. This one in green. Okay, so constant term. Our constant term is 3. So things that multiply get 3 are just 3 and 1. So I've got plus or minus 3, plus or minus 1. Those are my factors of my constant term. Notice that we do not have a leading coefficient, or we don't appear to have one. But remember, there's an implied number in front of every variable expression. It's 1. The coefficient's 1 if there is no coefficient. So things that multiply to get 1 are just 1. So this is a nice and simple one. Our only solutions are plus or minus 3 over 1, which is plus or minus 3, and plus or minus 1 over 1, which is plus or minus 1. And those are all of the numbers, those 4, 3, negative 3, 1, and negative 1, are the only factors, the only rational numbers that could be factors of this. All right, well, let's think about what that means. let's think about what that means. If these are the only factors, or the only potential factors, then what I could do with this is I could divide each one of the, I could like test out the individual factors using the factor theorem by dividing each one into this, each resulting factor into this original polynomial with synthetic division. And if, when I do that, when I get my remainder over here, if the remainder is 0, so if this remainder here, if the remainder equals 0, then you found a factor, like a legit factor of your polynomial. That's what the factor theorem tells us. If the remainder is 0 when you divide, then you found a factor that works. So for example, let's say I wanted to first try positive 3 here. I wanted to try positive 3. So I want to try positive 3 first, which means I put 3 right here, which means I'm dividing this by x minus 3. So if I went and did this, and I said, okay, we got 1, -4, 5, and 3. Bring it down, here we go. 1 times 3 is 3, -1, 3 times -1 is -3, 2, 3 times 2 is 6. Oh, not equal to 0. So that means that x minus 3 is not a factor. So then I'd have to try another one. Let's see which one of these actually works. 1, nope, -1. Well, anyway, what you'll do is you'll keep working through these until you find one that works, and then you'll proceed. I'll show you that on the next slide. All right, so again, as I started talking about previously, we want to be able to solve a polynomial equation using the rational zero test and the factor theorem. So here, these are the steps. You're first going to find the possible rational zeros. So we want to find the possible rational zeros. Why we want to do this is because we want a list of potential zeros that we can individually try each one until we find one that actually is a 0. And then that's the same thing. Once we find one that is a 0, it's almost the same thing as this problem, where we, rather than being told it was a 0, we found out it was a 0. Then we'd kind of proceed as we did in this original problem, when we were told it was a 0 rather than we found out it was a 0. That's the only difference. So we're using our list of possible rational zeros and dividing each one with synthetic division into our original polynomial until we find one that works, so to speak. And by working, I mean we want its remainder to be 0. All right, so we're listing the possible rational zeros. So we want all the factors of the constant term, 2, over all the factors of the leading coefficient. That would be 1 here. So all we have is plus or minus. Things that multiply to get 2 are 2 and 1. And then things that multiply to get 1 are just 1. And we didn't need that plus or minus down there. So for our possible rational zeros, we've just got plus or minus 2. That's 2 over 1. And plus or minus 1 over 1. So that's plus or minus 1. We only have 4 different zeros we got to try. Okay. It's always best to start with 1 if those are zeros, because those are easy to multiply and do synthetic division with. So we're figuring out which one of these, if any, and it might be none, but hint, hint, there is one, at least one that works. We want to divide with synthetic division until we find one that works. So let's find one that works. I'm going to start with 1 because that's the easiest one. Start with 1. So that means we're going to be dividing this. We're going to divide this by x minus 1, which means 1 goes here. So there we go. Coefficients. 1, 1, -4, and 2. And remember, we're looking for a remainder of 0. We want a 0 right here. That's when we know we can finish this problem with the quadratic formula. All right. So 1 comes down. 1 times 1 is 1. There we go. 1 times 2 is 2. Oh man, I got lucky. 1 times negative 2 is negative 2. And we got 0 on the first try. We got 0 on the first try. But let's pretend for a second that we didn't get this first. Let's say we did negative 1 first. And let's say we did this one first. Let's just pretend for a moment. All right, still doing our thing here. 1 comes down. Negative 1 times negative 1 is negative 1. 0. 0, negative 4. All right, 4. Then we add these down and we get 6. So what this means, because we got 6 here, because this does not equal 0, we know that x plus 1 is not a factor. So we essentially eliminate this. We are done with this because we didn't get 0. You got to keep trying all of these values. So out of our positive 1 and negative 1, we knew negative 1 didn't work. So we can try positive 1. And we found, look at this. Positive 1 did work. That means that this right here that I'm circling in black right now, this right here, because when we divided by x minus 1, we got a remainder of 0, that means that x minus 1 is a factor, which means you can factor it out. And you're left with, remember, this was the x cubed term, so this is going to be an x squared term. So we got x squared plus 2x minus 2 equals 0. And now, since we've rewritten this thing in black as a binomial times a quadratic, we can now solve it completely. So we got x equals 1 is our first 0. And we're going to solve for the remaining zeros by solving for the zeros of the quotient using the quadratic formula. This is the result of our division. So we are finding once we've found one that gets to 0, we're making this work. So we are using the quadratic formula to solve this. All right, quadratic formula time. We get x is equal to negative b, it's negative 2, plus or minus the square root of 2 squared, that's b squared, minus 4 times a, which is 1, that's a 1 right there, times c, which is negative 2, all over 2a, which is 2 times 1. So we've got negative 2 plus or minus the square root of 4 plus 8. That's a negative and a negative positive, 4 plus 8, all over 2. So negative 2 plus or minus the square root of 12, all over 2. And this is close to the right answer, but we can actually reduce this because we have the square root of 12 right here. The square root of 12 reduces into 4 times 3 and 2 times 2. So it's 2 root 3. We got negative 2 plus or minus 2 root 3 all over 2. And now, since they can all reduce, I can divide each of these coefficients by 2. I can do that. And I get negative 1 plus or minus the square root of 3. So my solutions are x equals 1 and x equals negative 1 plus or minus the square root of 3. All right, your turn. Pause the video, attempt the problem below, unpause when ready. Also, take a break too if you need to. Take a quick little, get up, walk around, take a break. These are a good time to take a break before you do these problems, before or after. All right, so you've unpaused the video. Let's go ahead and solve the polynomial equation. All right, we're using the steps in the previous slides. First, we want our possible rational zeros because we need a list of potential zeros to try with synthetic division with our function or with our polynomial to then be able to figure out, all right, which ones are actually our zeros. So possible rational zeros. We want all the factors of the constant term, so that'd be 3. So our constant term over the leading coefficient, which is 1, our leading coefficient. So we've got plus or minus. Things that multiply to get 3 are just 3 and 1. So plus or minus 3 and plus or minus 1. All over things that multiply to get 1 are just 1. This will be an easy one. Just we got 3 over 1 and 1 over 1. So it's plus or minus 3 and plus or minus 1. So we've got 4 possible zeros that we need to try. All right, let's start trying them. Again, we want to start with 1 and negative 1. I'm going to break my rule because I think 1 and negative 1 are ones that actually work. So I want to go through the list and show you guys how you might have to do a few. So we're going to try 3 and negative 3 first. So 3. 1, 4. Don't forget your 0 term for the x term. So 1, negative 4, 0, and 3 are our. So 1, negative 4, 0, and 3. So we are looking for a 0 remainder. All right, let's bring it down. Bring down our 1. 1 times 3 is 3. 1 times negative 3, it's negative 3. Negative 3 times 3 is negative 9. That's negative 6. So this one does not work. That's a no. All right, so we try another one. Let's try negative 3. All right, again, 1, negative 4, 0, and 3. Bring down our 1. Negative 3 times 1 is negative 3. Add these, you get negative 7. 21, these numbers are getting too big. This is definitely not going to work. Negative 63, that's negative 60. So that one does not work either. No. All right, so we start trying our 1 and our negative 1, which is what we should have done started with from the beginning. So let's do 1 now. That means x minus 1 would be a factor. So hopefully this one works. All right, bring down our 1. 1 times 1 is 1, times negative 3. 1 times negative 3 is negative 3. All right, we're in business. 1 times negative 3 is negative 3, and we get 0 as our remainder. So that means, yay, we got it. That means that this is our resulting. So we're not done, but we can continue from this. So what this means, I'm going to rewrite it up here. We've rewritten this polynomial as, since 1 worked, we know x minus 1 is a factor. And this result, x squared, remember that's 1x squared minus 3x minus 3. So it's x squared minus 3x minus 3 is equal to 0. So we've rewritten our original polynomial as this, using our guess and check method almost with synthetic division. All right, so now we know that x equals 1 is one of our answers from our zero product property. Now we got to find the answers that come from these, and there'll be 2 of them, and we get them from the quadratic formula. Hopefully you're thinking that to yourself. So x is equal to negative b, that's negative 3, so 3 plus or minus the square root of b squared, that's negative 3 squared, minus 4 times 1 times negative 3, all over 2 times 1. So here we go. 3 plus or minus, I got 9 plus 12, all over 2. 3 plus or minus the square root of 21, all over 2. And now we think, okay, does root 21 factor? Well, 21, 7 and 3, it does not. Those are both prime numbers, so it does not simplify beyond the square root of 21. So our 2 solutions are x equals 1 and x equals 3 plus or minus the square root of 21 over 2. And remember, I said 2 solutions, but I meant 3. Because remember that what's circled in this pink color is 2 solutions, 3 plus and minus root 21 over 2. And then x equals 1. So 3 solutions, then that's it. We are done. On the next slide, there's the exit ticket for the classroom. Go ahead and knock that out.